This problem right here requires a process called z substitution, where I'm going to let this entire expression, 3y minus 6, that's located both here and here, I'm going to let that be represented by the letter z. So it's going to make it a little easier to work with. So what we do is, instead of 3y minus 6, I'm going to plug in a z. So I'm going to get a z squared instead of 3y minus 6 squared, minus 12 instead of 3y minus 6, I'm going to get now a z, and then equals negative 36. I'm going to pull the negative 36 over by adding it to this side, and it's going to be equal to 0. Now notice what I have. I have a quadratic equation that is nice and easy to solve. So I can factor this, and I'm going to get z minus 6 times z minus 6 equals 0. So if I solve this for z, I set each of these parts equal to 0, so z minus 6 equals 0. It's going to be the same thing for the other part, so when I solve this, I get one answer, z is going to equal 6. Now I substitute again, where z, remember, is a whole entire expression, 3y minus 6. So 3y minus 6 is actually what's equaling 6. So when I solve this, I can add 6 to both sides. I get 3y equals 12. So my final answer is y would equal 4.